Good evening, everyone. Okay, so we plan to meet on Zoom, but due to network problems, I don't think we can do it. So I'm just taking this opportunity to record this video for you so that when you look at it, you understand the ESALs and how you go about the whole procedure. Okay, so first of all, we have been given the vehicle types. We have large bus, light truck, medium truck, heavy truck, extra heavy to extra truck trailer. We've been given their axle loads, we've been given the number of axles. We have 2,
light truck we have 2, medium 2, heavy 3, extra heavy 4, and so on. Then you come to the sample size. So the sample size is just referring to the number of vehicles that were weighed. So when you have large bus, how many large buses were weighed? You have 15 of them. Okay. When you go to light truck, we have 1, medium truck 5, heavy truck 25, extra heavy truck 11. Then to extra truck trailer 57 and so on. Then you go to the average ESAL. The average ESAL. Okay. So these average ESAL, they are representing the track factors. You see that for large bus you have 3.5315. For light truck we have 2.3543 and so on. To extra truck trailer with 61.4032. So what this means is that per each pass of a large bus, the effect or the damage caused by one pass, just a single pass of large bus, is 3.5315 times your standard the effects that the standard axle will cause. Okay, so we have our track factors given, and before I proceed, you can see that we have 2 directions, Kumasi to Accra direction and also Accra to Kumasi. I meant this Kumasi to Accra and Accra to Kumasi. Very good. So these are showing you like the directions in which the vehicle types were weighed. So before we go on, these Accra to Kumasi and Kumasi to Accra, they are just giving us directions. So the sample sizes are like Kumasi to Accra, large bus we had 15. When you come to Accra to Kumasi, we had large buses 12. You come here, light truck 1, light truck 7. Very good. So this is what you are supposed to do. These numbers are here to represent the number of trucks that were weighed. So in the day, or this sorry, I didn't mention that these data, they are for 3-day survey. So it will have an effect on the whole computation. We will get there. When we get there, I'll just tell you. Okay, so I've discussed the data that has been given. Let's move to the next slide. Okay, so on the next slide, what we are going to do here is that we want to know the direction with the maximum traffic. So we first of all, we are going to calculate in which direction do we have the highest traffic. So we sum the Accra to Kumasi direction and the Kumasi to Accra direction to get like the total volume, the total two-way volume of vehicles. So here 12 plus 15 you get 27, 7 plus 1 you get 8, 6 plus 5, you get 11, like that. Okay, so after getting this, you sum everything here in this column to get the 420. This 420 is representing the sum of all the tracks, or the sum of everything that's here. It will be 420. Okay, so after the 420, we want the direction with the highest. So in Accra to Kumasi direction, how many do we have? 241. After summing these whole thing. Kumasi to Accra, how many do we have? 179. After summing this whole thing. Then we take 241 as a percentage of 420. Okay, so what we are going to have is that you have 241 over 420 times 100, and it will result in 57.38%. Then you do the same thing for Kumasi to Accra, and you get, that's 179 over 420 to get 42.62%. Very good. Then the next thing that you do is to calculate the percent of each vehicle in the total. So when you pick medium buses, the total medium buses that were counted over the total vehicles counted. So this 27 over this 420 by 100% will give us the 6.4. Then you come here, the 8 over 420 by 100 will give you 1.9. You do same for all of them, and after everything, when you sum everything here, you must get 100 because you are dealing in percentages. Very good. So let's continue. After getting this one, we are going to use it somewhere. That's why we've calculated it. We are going to use it in the next slide. Okay, so let's move on to the next slide and see what is happening over there. Okay, so we come here. We have our vehicle class here, and here we are interested in the AADT. This table is going to show you the calculation for the AADT. That's it, this year's AADT. Okay, so 2024 AADT. That's what we are about to calculate. You need the monthly factors, the hourly factors, the ADT, the 3-day two-way volume. Okay, because the survey was a 3-day survey, that's why you could see 3-day two-way volume. Very good. So the 27 that you see at the large bars are under the two-way volume. It is just the sum of the volumes in both directions. So it is this one, this 27 that has been replicated there. Very good. So we have 27, 8, 11, 53, 29, 42, etc., etc. to 158. Okay, so these are 3-day two-way volume. Okay, and mind you, they worked from 6 a.m. to 6 p.m. so that's like 12 hours. Okay, so here we have, on the next column, we have 12-hour average daily traffic. 12-hour average daily traffic. With the 12-hour average daily traffic, we are just going to divide the 3-day count by 3 to get like a 1-day count, or we are finding the average. Yes, so 27 over 3 you have 9, 8 over 3 you have 2.7, 11 over 3 you have that, and so on. Very good. So from here we only have 12-hour average daily traffic. We don't have a 24-hour average daily traffic. And mind you, our AADT, it's recorded in 24 hours. So we have to adjust the 12 hour to 24 hour, and by so doing we have to apply hourly factors. So in the manual for something road, I've forgotten. You see, before you can convert the 12-hour ADT to 24-hour, you have to apply hourly factor of 1.33, which is for low volume roads. So we apply the 1.33 throughout. So that's going to result in 1.33 multiplying 12-hour, which is 9.0, 1.33 multiplying the 2.7, like that, and so on. Okay, after this, after multiplying by the hourly factor or hourly factors, it's going to convert it to 24-hour count. So after the 24-hour, you have to also factor it to the monthly. So we factor it to the monthly, and mind you, this data was collected in February, so we have to apply a monthly factor of 1.0, and these monthly factors are in the GHA design manual. You find all of them there. So 1.0, 1.0, 1.0, 1.0 throughout, and this will result in our AADT. So our AADT will be a multiple factor of the monthly factor, the hourly factor, and the 12-hour average daily traffic. After getting the AADT, then you sum everything under the AADT, and that will result in your total 2024 AADT, and I had 186.2. Okay, so from there, the next thing you do, we are here to calculate our design ESALs. And you know, before you can calculate your design ESALs, you have to know your AADT in the base year. So we explained that the base year is the year the road will be open to traffic. So if we are in 2024, considering all construction operations and other things, construction delays and other things, I assume that, or I chose that my base year will be in 2030. So we would need AADT in 2030, and this is not difficult. This is just the old formula that you know now that you are going to apply here. Where is it? So you are going to apply, I'm coming. You are going to apply AADT 2030 should be equal to your AADT 2024 in a bracket 1 plus your annual growth rate, which is your R, to the power I, where I is your the time interval between now and your base year. So the time interval from now, which is 2024 to 2030, and you get 6. So after doing that, you are going to obtain your AADT in 2030. So after obtaining the AADT in 2030, the value that you get, I had 270. That's what's written here. The value that you get, you come and with your percent AADT that you found in the 2024, you multiply it by the 2030 AADT to get the composition or the component of each of the vehicle types in the 2030 AADT. I don't know whether you get it. So we are using these percentages are from the 2024 AADT that we calculated. That's on this slide. Here, these percentages. Okay, so you put those percentages here. So 2030 AADT. With the 2030 AADT, what is going to happen is that you just multiply this 6.4% by your 2030 AADT that you've estimated, which is the 270. So here 6.4% times 270 will result in 17.28. 1.9% by 270 will result in this. We do same for all of them and we'll get this. At the end, when you sum all of them, you are supposed to get your 270 back. Very good. Then we move on to the design lane AADT. With the design lane AADT, you already know the lane with the highest traffic. So when we calculated, it was 57.38. That's the directional split. Okay, so you put the design lane is your current AADT times, no, I'm saying the base year AADT times your split, your directional split. So because we always design for the direction with the large traffic volume, so we take the 57.38% and multiply it by the 2030 AADT. So here 17.28 by 57.38%, you get 9.99 and 9.9. You do same for here, you get this, you do same, you get this to this point. Then from here you go to the next column, which is design lane AADT. With your design lane AADT, what you are going to do is that here you have to know the number of lanes you are designing. So if you are designing a 2-lane, one in each direction, you know that your design lane factor will be 1. If it is 6 lanes, 4 lanes, 2 in each direction, you know what it will be. They are all in the table, so I don't have to talk much about it. So I am doing a 2-lane, so one in each direction. So I chose a factor of 1 and I multiply through by the 1 multiplied by the design lane AADT. Very good. So from here, the next thing that you do is that you are going to estimate your design periods traffic. So I am using 15-year design period. I don't know, you can choose any design period that you want. That's your own engineering judgment and other stuffs. So I chose 15-year design period, and with that I had to estimate the growth factor based on the design period. There is a formula for that. The formula, I think I have it here. So this is what I was talking about. So total lanes in both directions. If it is 2, your lane distribution factor is 1. If it is 4, it is 0.9, and so on. Okay. So this is the G I'm talking about. The P is your design period in years. You have to estimate the G, and your R is your annual traffic growth rate, which you can get from historical data or any other means that is explainable. So you estimate your G using this formula, and you are going to use it in your design traffic estimation. So I had my G to be 21.58 and my R to be 5%. You are not supposed to use R of 5%. I mean, don't stick to 5%. You can use 6%, 4%. It all depends on what you are doing and your explanation to it. So don't stick to this and use it as if it is the only thing that you can use. Okay. So 15-year design period, design traffic. What you are going to do here is that you are going to multiply your design lane AADT, which is 9.92, by your growth factor, which is 21.58, by 365 days. Okay, so after multiplying what I said, your growth factor G, your design lane AADT, which is here I have 9.92 as the first one for the large bus, and you multiply by 365, you're going to get the design traffic, which has 78099.56. From here, you are almost done. The only thing that is left is to introduce your track factors. Okay, so here, because of the lane that we are designing for the 57.38% lane, and the track factors that you use should be the track factor of the lane that you are distributing, the lane that you are designing for, if you have it. Here we are lucky that we have that lane's track factors, and they even proved to be the highest among the two track factors that were given in terms of the directions. So I will advise you to choose that one as your track factors. You can also decide to find the average, but mind you, the average is going to result in a reduced track factor, and I don't know what will be the implication, but designing for the maximum I think is the best other than the average. It depends on you. You can choose to design for the average, or you can choose to design for the lesser one. It all depends on you and how you explain it to the panel. Okay, so from here I put the track factors for the lane that I'm designing for, which is the one with the maximum traffic volume, and which happens to be the Accra to Kumasi lane, where they had track factors of these. Okay, so this is what I'm talking about, this part. Because when you compare these values to these values, obviously you could see that these ones are having much bigger values than this one. So it is advisable to choose the maximum because we design against the worst case. So I'm choosing the one with the maximum track factors. Okay, so let's quickly move on. So I have the track factors 3.8485. I multiply these track factors by the design traffic to get my design ESALs. After that, I sum everything. Don't mind the zeros in between here. I had to make some corrections because of the spaces that I left inside. That's why you could see some zeros here and there. It doesn't really count, so forget about them. After summing everything, you result in your total design ESALs. So that is what I have here, and I think I'll end my presentation here. And if you have any question that you would want to ask, you can send it to my DM. My name is Marvin Oseiwufo, and it is nice to meet you all. Have a good evening. Bye.